Hi everyone! In this Mission to Mars video, we're going to be talking about the next step in developing a mission to Mars, and that's landing on Mars. Joining us today to help us understand how we do that is Arissa Stilley, an EDL engineer on the Mars Perseverance rover. Arissa, thanks for joining us today and welcome.
Hi, thanks for having me.
My first question has to do with the letters E, D, L. I hear those letters a lot when talking with people about landing on Mars. What does that mean?
So EDL stands for entry, descent, and landing. So for entry, that's when we begin to enter the atmosphere of that planet. Descent tends to be the part where for us at Mars, we're often on parachutes and then on rockets as we slow down. And then landing, of course, is getting the vehicle or the payload safely on the surface. And it's really meant to describe the process of us taking a vehicle that has been traveling to another planet and getting it safely to the surface of that planet.
Now, what factors do you take into consideration when it comes to landing on Mars?
Well, one of the things you really need to think about is what the environment is like where you're going. So there are a couple of specific things about Mars that are different. For example, the atmosphere is thinner. It's only 1% or so of the atmosphere we have at Earth. So there's less air molecules to slow you down during EDL. Another difference is gravity. Gravity on Mars is less than Earth. So that affects the calculations that you would make, like how much thrust you need near the surface. And then what does the ground look like? Where are you trying to land? In the landing that we have for Perseverance at Jezero Crater, it turns out it's full of rocks, it has a cliffside, and it has sand dunes everywhere. So in order to make something that can land there, we need to think about where it is that we're going.
With that in mind, what are some of the forces that are acting on the spacecraft during landing?
So when we land a vehicle on Mars, we're often coming in around 12,000 miles per hour and have to slow down the spacecraft to something like 2 miles per hour by the time it touches down. Perseverance flies through the Martian atmosphere, similar to how something would fly through the air on Earth. So some forces that are common when you're flying are lift and drag. Lift is the force that pushes up the vehicle or lets it fly. And for a mission like Perseverance or Curiosity, we actually use that lift vector to steer ourselves during entry to better hit the target that we're trying to reach on the ground. The other force, drag, is the force that is trying to slow something down. So if you think about riding in a car and someone slams on the brakes really hard, that's similar to the deceleration that the spacecraft feels as it's coming into the atmosphere and slowing down very quickly. Because we come into Mars so fast, another thing you have to think about are the materials you're going to put on the bottom of the spacecraft to protect it while all of this heat and friction are being built up because of the speeds. Our heat shield can get up to 1600 degrees Celsius for the Perseverance rover mission.
Now, when it comes to actually landing, how are you controlling the spacecraft?
So EDL happens on its own or autonomously. It typically takes anywhere from 10 to 12 minutes for a signal from the spacecraft to get back to Earth. To do EDL well, we have to first set up the vehicle to have our best knowledge of where it is and how fast it's moving at a specific time. And using sensors, we'll tell it when to do the next thing in the EDL sequence, whether that's deploying a parachute or releasing the parachute and turning on the rocket engines. For the Perseverance mission, we have a new system where it can take a picture and the rover's computer brain can pick a safe landing site by comparing that picture to a map on board, seeing where it's at exactly, how far it can go at that point in time, and then it'll fly to a safe spot on the ground.
That sounds like a very complex process that must take a lot of planning. Now, when I've seen videos of landings happening on Mars, I see people cheering and crying and getting very excited. Why is it such an emotional experience?
When you think about landing something on Mars, it kind of feels like you only get one shot, and that's pretty true. You work really hard to try and think of everything that needs to happen, everything that can go wrong, and there's a great sense of both joy and relief if and when it actually goes well. Think about how excited you get if your team wins at a sport. It could be basketball, football, a dance competition. You've spent so much of your time learning and then practicing, and the further you get, the more that's at stake in terms of your personal investment. So that's how it feels by the time you reach the day of actually landing on Mars. It's super exciting, it's super relieving, so all the emotions just bubble up and come out.
I want to thank you for taking time today to talk with us about landing on Mars, the next step in a mission to Mars.
Thank you so much for letting me help teach the next generation of explorers how to land on Mars.
Now that we've heard why this is so important, you're ready to land on Mars. Stay tuned for the next step in your mission to Mars, and that's surface operations.